Okay, so in acids and bases, we can perform neutralizations by the same method we performed dilutions back when we talked about solutions. We know that in an acid-base neutralization, an acid plus a base, if they are of equal concentration, will neutralize each other completely, producing salt and water. And if they are not of equal concentration, then we know we'll either produce whatever is left over, a weak acid or a weak base. But if they are in equal concentrations, we produce salt and water. And the formula for those dilutions is the same formula we saw or formula for those neutralizations, excuse me, is the same formula we saw with dilution. M1V1 equals M2V2. And again, just like we did with dilutions, you watch your units for volume. Milliliters and liters do not cancel, and you have to convert if you're given one and the other as your volume. So you have to make sure that they're consistent. So we're just going to run through two of these. They are very simple. If you understood dilutions, neutralizations is a piece of cake. So what volume of 0.15 molar potassium hydroxide is neutralized by 30.0 milliliters of 0.25 molar hydrochloric acid? So this is my base, and this is its M1. This is my acid. This is my V2, and this is my M2. So I'm solving for V1. And just like I did before, set up, multiply, and divide. So 0.15 times V1 equals 0.25 times 30.0. Multiply, divide, and that is giving me a V1 to 2 sig figs of 50 milliliters. So how much potassium hydroxide at 0.15 molar is neutralized by 30 mils of 0.25 molar hydrochloric acid? 50. That's it. Okay. Same thing like you saw with dilutions, just different words. How many liters of 6 molar sulfuric acid is required to neutralize 2.4 liters of 10.0 molar sodium hydroxide? So this is my M1, this is my V2, this is my M2. Okay, I'm going to set up 6.0. V1 equals 10.0 2.4. That's really messy. 2.4, there we go. Multiply, divide, that gives me a V1 of 4.0 liters. Okay, easy as pie.